Hello, ladies and gentlemen. Welcome to Math 31, Calculus, Chapter 2, Lesson 10, Higher Derivatives, Part 1. Now, today we're going to be doing quite a few things. We're going to be illustrating second, third, and higher derivatives of algebraic functions. We're going to be finding the second and third derivatives of functions. We're going to be showing that equivalent forms of the derivative of a rational function can be found by using the product and the quotient rules. And we're going to be determining the second derivative of an implicitly defined function. Now, the second derivative is found by taking the derivative of the derivative. Now, you can continue to differentiate as long as there's differentiability. Now, I want to also note here some notations include f prime of x, that's the first derivative, f double prime of x, that's the second. First, second, third, f triple prime. Now, that many prime marks, it starts getting messy. So quite often we will put it in brackets. It's not f to the fourth power, it's the fourth derivative. Be careful of that. Now, Leibniz notation might see dy dx, d squared x or dx squared, that's the second derivative. The third derivative, d cubed y over dx cubed, d to the fourth y over dx to the fourth. First, second, third, fourth derivative. Now, let's go here. Find the first four derivatives for the function y equals x to the fourth plus 3x cubed minus 2x squared plus 8x. Well, y prime of the first derivative will be 4x cubed plus 9x squared minus 4x, sorry. Alright, the second derivative would be 12x squared plus 18x minus 4. The third derivative is 24x plus 18. And the fourth derivative, and you see why I write this like this, f to the fourth in brackets would be 24. Alright, now, so far so good. Nothing particularly hard here, but one thing to note, decreasing power. Alright. So, sorry, I'm just looking, how did I word that earlier? Decreasing, yeah, decreasing power, or exponent. Notice we started with x to the fourth, and ended up with x to the 0. It goes down one full power every step. X fourth, x cubed, x squared, x to the 1, x to the 0. If we kept on going, it would be 0, because the derivative of a constant is 0. That's why we stopped at the fourth. Now, here we go. Find the second derivative of y by implicit... Now, why am I saying implicit differentiation? No, you'd be using the quotient rule here. Implicit differentiation is a different one. My apologies, ladies and gentlemen. Anyway, so the derivative here now is, let's see, g of x times f prime of x minus f of x g prime of x. I have to write this out after that embarrassing episode where I showed you the chain rule and I couldn't remember it. Sorry, the quotient rule, not the chain rule. G of x squared. Never hurts to write out the formula. So the first derivative here, 2x plus 1, g of x times the derivative, 6x minus 3x squared times the derivative of the denominator, which is 2, over 2x plus 1 squared. So, foiling this, we get 12x squared plus 6x minus 6x squared over 2x plus 1 squared. That simplifies to 6x squared plus 6x over 2x plus 1 squared. Alright? Yes, I got it right this time. It's actually the third time I've done this video because I keep doing stupid math mistakes here. So many steps, nothing particularly hard, just so many steps. Now, so far so good? Well, that's the first derivative. Now note here, I can factor out 6x, x plus 1 over bracket 2x plus 1 squared. Now, I would attempt to do it that way just so I can see if I can cancel stuff out. I can't. The other problem is I've got to take the derivative of this again. If I use this, I've got something times something, so I have to use the product rule. So I wouldn't do that. I'd leave it like this, where it's actually a little simpler to find the derivative. So, this one more time. So g of x becomes 2x plus 1 squared. F prime is the derivative of 6x squared plus 6x, which becomes 12x plus 6. F of x is 6x squared plus 6x times the derivative of our denominator, which we would use a chain rule, so that's 2 times 2x plus 1 times the derivative of 2x, which is 2. All of that would be over 2x plus 1 to the 4th. All right? So far so good-ish. All right. Deep breath, because now we have to do some simplifying. Once again, it's 2 or 3 steps to come up with the final equation, or the equation, but it's 2 pages to simplify. Now please note here, notice I refuse to FOIL out the denominator because sometimes it cancels out. In this instance, it does. We can cancel out a 2x plus 1 in each term. So right off the bat, that makes the math much simpler. So now I'd have to FOIL the numerator, hoping to get more stuff to cancel out. So that's 24x squared plus 12x plus 12x plus 6 minus 4. Oh, that's 2 times 2 is 4, so that's 24x squared plus 24x over. Now, can I cancel anything else out? Well, yes, I can. I should write it all out, get rid of the brackets here, but this is minus. So this is minus 24x squared plus 24x squared. That will cancel. And we have minus 24x plus 12x plus 12x. Oh, that all cancels. That's neat. So we're down to 6 over 2x plus 1 cubed. Okay? So that's finding the second derivative. And it's not bad if you don't make a stupid math mistake. Anyway, as I said, this is the 3rd time I've made this particular video because I keep making dumb math boo-boos. Plus becomes a minus. Anyway. So, that's finding the second derivative. That's what I need you to be able to do. Now, I'm going to pause the recording here because if I keep on going and make another mistake, and I have to erase the video. Any questions, shoot me an email. Otherwise, good luck.